Greetings, everyone. In the last class, we talked about measures of central tendency, measures of variation, and graphical tools. We use these tools to describe the characteristics of variables and to get a rough idea about a sample. With this descriptive information, we can also understand individual scores better. If I told you a student got a score of 55 on the test, would you know what that means? Not really. A single score means nothing without a frame of reference. In other words, a score is only meaningful when compared to other scores in the distribution. In this video, I'm going to talk about tools that help us understand individual scores. These include percentiles, percentile ranks, and standard scores. We have all heard of percentiles before. A percentile is a point in a distribution at or below which a certain percent of scores fall. For example, if a student got 165 on the GRE verbal test, and we know the distribution of GRE scores, we can see that 165 has a percentile rank of 85. This means 85% of GRE takers scored at or below 165 on the verbal exam. Percentiles and percentile ranks are two sides of the same idea. Percentiles are raw scores, and each raw score has a percentile rank in the distribution. The simplest way to tell them apart is this. A percentile is a score on the original measurement scale. For example, GRE verbal score range from 130 to 170. Each score has a percentile rank. Percentile ranks range from 0 to 100%. So the 85th percentile is a score of 165, and the score of 165 has a percentile rank of 85. Raw scores are usually ratio variables. So percentiles are ratio variables too. Percentile ranks are different. They are not equal interval scales. They are ordinal, so they cannot be meaningfully averaged. For example, many students have GRE's verbal scores around 150. The interval between the 50th and the 60th percentile ranks is only 1 point, from 150 to 151. But the interval between the 80th and 90th percentiles is 3 points, from 158 to 161. Because the distances are unequal, percentile ranks are ordinal and not the best tool for describing the relative standing of scores. In comparison, standard scores are the best way to interpret individual scores. A standard score, also called a z-score, tells us how many standard deviations a score is above or below the mean. It is a relative measure of position in the distribution. To calculate a z-score, we subtract the mean from the raw score and divide the difference by the standard deviation. For example, if a set of scores has a mean of 50 and a standard deviation of 5, then a raw score of 55 have a z-score of 1. This is because 55 minus 50 equals 5, and 5 divided by 5 is 1. A positive z-score means the raw score is above the mean. A negative z-score means the raw score is below the mean. any score can be converted into a z-score. This process is called standardization. Standard scores have two key properties. First, if all raw scores are converted into z-scores, the distribution keeps the same shape but now has a mean of 0 and a standard deviation of 1. Second, z-scores are ratio variables. This makes it easy to compare how high or low a score is relative to others in the distribution. Another important use of these scores is comparison across different distributions. Because all variables can be standardized, scores from tests with different means and standard deviations can be compared. For example, a student scored 55 on a math test with a mean of 50 and a standard deviation of 5. The same student scored 90 on a reading test with a mean of 100 and a standard deviation of 10. Converting them, the math score had a z-score of 1, and the reading score had a z-score of -1. Even though the raw reading score is higher, the student actually performed better in math relative to peers. This example shows that standard scores let us compare distributions with different scales that have different means and standard deviations. Finally, let's talk about outliers. Outliers are unusual scores that are extreme and need special attention. There is a rule of thumb to identify them. Scores above the reasonable upper boundary or below the reasonable lower boundary are considered as potential outliers. The upper boundary is the 75th percentile, the third quartile, plus 1.5 times the interquartile range. The lower boundary is the 25th percentile, which is the first quartile, minus 1.5 times the interquartile range. The interquartile range is the difference between the 75th and 25th percentile scores. For example, if the 25th percentile score is 50 and the 75th percentile score is 70, the interquartile range is 70 minus 50 equals 20. The upper boundary is 70 plus 1.5 times 20 equals 100. The lower boundary is 50 minus 1.5 times 20 equals 20. So any score above 100 or below 20 may be an outlier. These scores should be checked carefully and compared with the rest of the distribution. Keep in mind, this rule of thumb does not replace good judgment. Graphical displays and context should also be used when identifying outliers.